Okay, so this is for 4-3. I know this is a bit late, and you guys were supposed to have this on Friday, but better late than never. So, what we're doing here is we're trying to figure out how to get the graph of, or rather the equation of a parabola that, given only the 3 points that it goes through. So, those are the 3 points that we're given. Negative, or 1, -1, this is the first problem. 2, -5, and 3, -7. So what we're going to do is we are going to take each one of these points, and so y equals ax squared plus bx plus c is the kind of generic form of the quadratic equation. So what we're going to do is we're going to take each one of those and we're going to plug those points in for x and y. And we're going to get 3 separate equations. So I'm going to color code this first one. I'm not going to color code all of them, but you can if you want, if that helps you. So we're going to take that we're going to take that 1 and plug it in for x, and the -1 and plug it in for y. So we get -1 equals a times 1 squared plus b times 1 plus c. It's going to be -1 equals a plus b plus c. Do the same thing with 2, -5. So if -5, that's my y, equals a times 2 squared plus b times 2 plus c. So it's going to give me -5 equals 4a plus 2b plus c. And finally, I'm going to do it with 3, -7. So I get -7 equals 3 squared a plus 3b plus c. So all I did there on this first step was I plugged in each of the points for x and y. So I have -7 equals 9a plus 3b plus c. Okay, so these are my 3 equations now. So what I'm going to do is I'm going to put them together, and so this is going back to the previous chapter when we had to solve equations with 3 variables. So same idea. So we have -5 equals 4a plus 2b plus c. And then we have negative, so we're going to subtract that equation. We have -1 equals a plus b plus c. So we're just subtracting the bottom equation from the top equation. So we're going to start off, we have -5 minus a -1. It's going to give me -4. Ooh, wrong button. Okay. -4. And the reason it's -4 instead of -6 is because we're subtracting it. And so we get -5 -1, or -5 plus 1, or -4. 4a minus a is 3a. 2b minus b is b. There you go, anything. So that's my cat. So now what we're going to do is we're going to subtract that same first equation, -1 equals a plus b plus c. So we're going to subtract black from purple. So again, we have this -7 minus a -1, or -7 plus 1, or -6, equals 9a minus a, or 8a, 3b minus b, or plus 2b. So these are 2 equations. Now, what I'm going to do is I'm going to multiply that green equation by -2. And the reason is I'm going to get rid of my b's. So I multiply the entire equation by -2. It's going to be positive 8 because I have -4 times -2 equals -6a minus 2b. Add those together and I get 2 equals 2a, or divide by 2 and I get a equals 1. Okay. So now that I have a equals 1, I can solve for b, because what I'm going to do is I'm going to take that a equals 1, I'm going to plug it back into -4 equals 3a plus b. So I have -4 equals 3 times 1 plus b. -4 equals 3 plus b. Subtract 3 from both sides, and I get b equals -7. So now I have b equals -7 and a equals 1. I'm going to plug them both into this equation right here. That was my first one. -1 equals a plus b plus c. So instead of a, I'm going to write a 1. Instead of b, I'm going to write a negative 7. And instead of c, well, I haven't found c yet, so I'm going to leave it there. So I'm going to have negative 1 equals negative 6 plus c. I'm going to add 6 to both sides. And I get c equals 5. So now I have a equals 1, b equals negative 7, c equals 5. So now that I've solved all three of them, I plug them back into my quadratic equation. And I get y equals x squared. That's a, because remember, what we're doing is we're plugging it back into this equation right there. Y equals ax squared plus bx plus c. A equals 1, so we have 1x squared. B equals negative 7, so we have minus 7x. And C equals 5. Okay, moving on. So, being that I'm going to be there tomorrow, and so I'm not going to go through all of them. I'm going to kind of pick and choose which ones. So I'm going to go through this next one, and then what I'll do is I will just kind of post the completed form. And it's going to be ugly and messy. There are going to be scribbles all around. But what I'll do is I'll kind of slowly unveil it. That way you can kind of hit, if you're trying to figure out how to do this, you can hit play and stop. So it'll be like this. First thing we do is we plug in our A, B's, and C's. We get those three equations. So in most of these, because we don't have a C already, it's going to make the most sense to eliminate C. Because they're all, the coefficient of all the C's are 1. Okay? So we combine the top two, and we get 1 equals 3a plus b. Combine the first and the last, and we get 0 equals 8a plus 2b. Multiply that first equation, 1 equals 3a plus b times negative 2. So that's going to get rid of my b's, and I get negative 2 equals 2a, or a equals negative 1. Plug that negative 1 back into 1 equals 3a plus 2, and I get b equals 4. Plug a equals negative 1 and b equals 4 into negative 4 equals a plus b plus c, and I get c equals negative 7. Now that I have my a equals negative 1, I get y equals negative x squared. B equals 4, so it's plus 4x. C equals negative 7 minus 7. So that right there in red, that's my equation. Same thing going forward. Plot my points, write my equations, combine. Now it's not always the first two, but this is what I'm doing. So I combine the first two, and I get 0 equals 5a plus b. I just subtracted the top one from the bottom one. Now I'm going to subtract the top one from the last one, the third one. And that gives me 12a equals, or 12 equals 32a plus 4b. So I'm going to multiply that one by 4, and I get 0 equals 20a minus 4b. That's a negative 4 is actually what I'm multiplying it by. So I get negative 20a. So I get 12 equals 12a. Divide both sides by 12, and I get a equals 1. Plug it back in over here. I get 0 equals 5a plus b. 0 equals 5 times 1 plus b, or b equals negative 5. Now I have to figure out which one I'm going to do. I'm going to plug it into that top one. So I have negative 8. So it's this equation right here that I'm plugging everything back into. So I have negative 8 equals 4 times a equals 1, plus 2 times b equals negative 5, plus c. So now that I only have c as my variable, I'm ready to go. And that is going to give me c equals negative 2. And then that up there, right there, this is my equation. Y equals negative, or y equals x squared minus 5x minus 2. Now, notice if I wanted to check this, I could take all three of my points, plug them in there for x and y, and all three of them would fit. Okay, that would be the next one. This one's a little bit trickier, so I'm actually going to go back and do this. Okay. So, notice what I did here was because I have that negative b there, I decided to get rid of my b's first. Okay, so what I'm going to do is I'm going to multiply my top equation first by 2, and I'm going to add it to my middle equation. So negative 12 times 2, negative 24. A times 2, 2a. Negative b times 2, negative 2b. Plus c is 2c. So that's going to give me negative 30 equals 6a plus 3c. Now I'm going to multiply that top equation by 4 and subtract it from the bottom equation. So I get 4 times negative 12, negative 48. 4 times a, 4a. 4 times negative b, negative 4b. And 4 times c is 4c. This is going to give me negative 60 equals 20a plus 5c. So these are my two equations right here. Okay, now here's the thing. If I were to try and multiply to get a common number, I'd be dealing in the hundreds here. So what I'm going to do is I'm not going to multiply by a whole number, I'm going to multiply by a fraction. And that's going to get rid of some of the coefficients. So I'm going to multiply that. This one right here, the negative 60 equals 28 plus 5c. I'm going to multiply that by 1/5. I can multiply it by 1/5 or 0.2 just the same way that I could multiply it by 5 or 10 or 6 or negative 37. So 1/5 times negative 60, negative 12, equals 1/5 times 20, 4a, plus 5 times 1/5, c. I'm going to multiply that one by a negative 1/3. Okay, so same general idea. Negative 1/3 times negative 30 is a positive 10. Negative 1/3 times 6a, 2a. Negative 2a, got to keep that negative there. And negative 1/3 times 3c is going to give me negative c. So now you can see what I did was I set it up to where the c's are going to eliminate each other. We're going to add negative 12 plus 10, negative 2, equals 4a minus 2a, or 2a. And the c's cancel out. So we're going to divide both sides by 2, and we're going to get a equals negative 1. And then from there, it's the same thing. Plug negative 1 back in. C equals negative 8. Plug a equals negative 1, c equals negative 8 into one of the top equations. And we get 3 equals negative b. Well, we don't care what negative b equals is. We want b equals. We're going to multiply by negative 1. We get b equals negative 3. So now we can write our equation y equals a, negative 1 times x squared, negative x squared. B, negative 3. So we're going to go minus 3x. Plus c, negative 8, so minus 8. And that's our quadratic equation. Now you can do it either way. If you wanted just to have it as y equals negative x squared, that's fine too. That's our next one. That's a blank page. That's ugly. Looks like... Here, let's go back a little bit. So we have... That makes more sense. Let's go back even further. Okay. That's what it should look like. So notice here, we don't have, we get a equals 1/2, b equals 3.5, and c equals 5. Now, because of this, because it's a little bit different, because we don't have whole numbers, I would advise always going back and checking your work, which is what all the other messy stuff was. But each of these, I go back in and plug in, and it works. So like 311, right? So if I go 3 squared, that's 9. 9 times negative 1/2 is negative 4.5. 3 times 3.5 is going to be 10.5. So I have 10.5 minus 4.5. 10.5 minus 4.5 is 6. 6 plus 5, 11. So my point 311 works. And the same thing would happen with 1, -1. Same thing would happen with 2, -2, -4. Okay? So you can always go back and plug your original points into the equation you got, and you're good to go. So notice here, because it goes through 0, 0 on this next one, your C equals 0. See, and we got that right off the top. So because we got C equals 0, we were able to eliminate C and just treat this like any other system of equations, like from Algebra 1. Okay, here's the next one. That actually looks all neat and pretty. Notice what happened here is our B equals 0. Okay, so we ran through our equation. We found that A equals 1, C equals -7, but B equals 0. So when we go back and plug that in, we have y equals 1x squared plus 0x minus 7, or y equals x squared minus 7. Okay, so okay. So for the last one, the word problem. So we have these 3 points, 132, 264, 474. And we're asked to find how many tickets are sold on day 7. And what's the maximum, on what day are the maximum number of tickets sold. So what we do is we just use those 3 points, 132, 264, 474, to get these 3 equations. And then, even though the number's a little bit bigger, we just work through the same way. We're going to eliminate our C's. And we end up with those 2 equations. 32 equals 3a plus b, and 10 equals 12a plus 2b. So we're going to subtract, we're going to multiply, actually, oh look, I saw it for b. So we're going to do a little substitution here. So we have 10 equals 12a, and then instead of 2b, we're going to write 2 times 32 minus 3a. So we have 10 equals 12a plus 64 minus 3a, or 6a. We're going to subtract 64 from both sides, so we get -54 equals 6a, or a equals -9. We're okay with that. Then, because we have 32 equals 3a plus b, we're going to plug in -9 in there. And we get b equals 59, c equals -22. And so that's our equation. Y equals -9x squared plus 59x minus 22. And then, so that's the equation. That's the equation of the parabola. That's part A. Part B is how many are sold on day 7. Well, then all we have to do is plug in 7 for x. Now I know it's t and n or something like that. I just used x and y. So we have y equals -9 times 7 squared plus 59 times 7 minus 22. So we have y equals -9 times 49 plus 59 times 7, or 413, minus 22. Now notice what happens here is I get -441 plus 413 minus 22. So y equals -46. Minus -463 plus 413, or y equals -50. Okay, so according to this, on day 7 we're going to sell -50 tickets. Well, you can't sell -50 tickets, so you just sit there and say 0. Okay? 0 tickets on day 7. So the second one asks for our, what day does it sell the max number of tickets. Now, remember when we were talking about our maximum, that's going to be the vertex. So we know the vertex is at -b over 2a. So we have -b over 2a. B is 59, so we're going to go negative 59 over 2 times 9, or negative 18. And that's going to give me about 3 point something, which means that the max number of tickets are going to be sold on day 4. And then it's going to go back down to 0. So the max number of tickets sold on any given day was day 4. We already know that to be 74. So if you have any questions, ask me tomorrow.